Welcome back to the stream. Alright, this is another kind of impromptu stream. Transitioning my desk here from kind of this whole complicated glitching project back to just gonna do some CAD work. Thank you, girl. I always forget to put a new card in this camera, and then it just greets me with this black screen. It's like it doesn't even boot up when there's no card in there. Anyway. Make sure my bandwidth is good. I need like a checklist of the many things I have to fuss with every time I start the stream. Hi everybody. Yeah, well I called it an impromptu stream, not necessarily because I wasn't expecting to stream at some point, but just the exact timing and subject matter of the streams usually ends up being less planned right now. I'm trying to get a feel right now for kind of what works, and I might be able to set up something a little bit more scheduled, but my main strategy for the streams is really just to have it be a fairly low impact way of documenting, stuff I'm already doing. I kind of found myself, having this, like I'm basically having this conversation with nobody when I'm recording my materials for the videos usually. And so if I stream that, it seemed like an easy way to create some additional ways for people to participate if they're interested. Duco's been around here. I think he's not quite ready to settle in somewhere, but when he's close by, I'll see if I can get the camera on him. Oh, greetings. Nice to see the friendly faces in the chat. So, yeah, I was just in the process of taking this apart, but figured I might as well get this on video while I'm doing so. This is a setup that you might have seen before in some previous streams. It's just kind of a work in progress attempt at creating a glitching harness for getting, for, among other things, potentially extracting firmware images out of these kind of Ethernet attached microcontrollers. There's been a lot of sub-projects involved. The one that I just finished up was kind of turning this other microcontroller, kind of another peer of the same type, into a just like a remote-controlled Ethernet interface that this Raspberry Pi can speak to. But I forget whether this is the kind you have to hold it down to turn it off or not. Yeah. Where is that power coming from? You see that? Oh, sorry, Tuco. This thing is supposed to be powered off, but these boards both have power LEDs. Is it still getting power through this connector? Guess so. Well then. Alright, I guess I'll just unplug that one. I'm not using it. Anyway, this project has been coming along, but the underclocking effort wasn't as successful as I'd hoped. I managed to hit a limit at around 5.5 megahertz on the input side, which seems like it's probably related to how the control loops in the Ethernet PHY are designed, and it seems difficult to get around. I wanted to bring that even lower because really I'm trying to slow down this other clock that's derived from that one that goes a lot faster. But I think I can get it. I think it's already just barely slow enough. I've got it down to, I just got this setup running at like 27 megahertz, which is totally something I can deal with. I just might need some slightly faster parts than what I'm using right now. Hey, Tuka. So that's making progress, but right now I'm anxious to switch gears back to some CAD modeling for the little button thing that we're doing. Alright, some objects. Objects. Physical objects. Like magnets, flex circuit, test print, and some more magnets. I was looking for my good calipers. I think they're over here somewhere. Hey Tuco, you don't want to step on any of that, do you? I'll leave this on the other desk where Tuco won't mess with it. I don't know where my calipers are, but I can at least get the CAD input devices. The computing setup for this is a little bit weird. I can't run my preferred CAD software on my usual demo machine, which isn't so much of a long-term problem since ultimately I want to be demoing CAD software that anyone can access pretty easily. And so expensive CAD software that's licensed per machine is not super compelling for that reason, but I'm using it for this project anyway as kind of a compromise for expediency's sake. It's something that I like, and I'm fast at using it, relatively speaking. And this project is not really about the CAD. That's just one aspect of it. Here's my calipers. I mean, this project is, I think, primarily utilitarian still, since I would like to just have this button pad for streaming purposes, but it was something that I could weave a few other threads into at the same time. Cat. I don't know what he's up to right now. I think we can be done with this O-scope too. So many wires around here. Alright, calipers, magnets, space, mouse, terrestrial keyboard. If I'm even going to care about this camera tonight, but I'll just put it somewhere. So, thank goodness for long USB extension cables at least. So I can at least put some input into the right computer. And cool. Tuco, are you going to join us? Okay, so now that things are a little bit set up, I have a couple of physical objects to look at. So I guess I can go back to this camera. So here's our prototype so far. And this is largely going to match what's already in CAD. There's a couple of things I might want to double check off of this physical object back into the CAD model. One is just the kind of total height of everything. It'd be good to measure the thickness of some of this without the paper backing. Subtract the paper is probably the easiest way to do that. And also the specific placement, especially kind of horizontally. So the amount of overlap between the pads on the Teensy and the flex circuit was something I kind of decided as I was attaching it. And as I make the model for the 3D printed case, I want it to reflect that. But I also want the model, I want the 3D printed part to not necessarily have to be too tight as far as the tolerances of that connection. So really, I think I want the 3D printed part to mostly grip onto this by the USB connector, and then kind of softly grab onto the edges of this, and then kind of gradually support this flex as it kind of gets thinner and more spindly. And as far as the zigzag goes, the actual thing isn't going to be zigzaggy. I think the actual thing will be more like a slab of material. But I might actually, hey Tugo. But, I might actually not, have that be super solid. I might have it be more of a kind of hollow structure so that I can make it more flexible. So to that end, I wanted to know what thicknesses of NinjaFlex would be applicable for different parts of this design. So actually, let's grab the CAD model for this briefly. Oh, is my mouse on? When I have that soundboard full of annoying sounds, I need something with a speak and spell saying USB problems. It's hard to tell which USB hub in the chain is having problems when it does this. Huh. I think the problem is with the, I think the 3D mouse might draw a little bit too much power from this internal hub. Or with this internal hub and everything else, such that when you plug the whole thing in. Okay, because now my mouse works. And I think now if I plug in my 3D mouse without trying to plug in everything at once, I think everything's fine. Yeah. Inrush current. Can't plug in the whole thing at once, but I can plug in the hub and then plug in the other devices. It could be a protocol thing, but my guess is inrush current. So, am I recording this? Yes. Things are good. Things are good in H.264 land and in Cat Town. So to get an idea for what, basically I wanted to know what the different thicknesses of NinjaFlex would feel like, and specifically how strong they would be behind the magnets I have. So I tried just printing a step pattern that goes up in increments of 0.15 millimeters, which is the layer height I usually use. So, and I think this is just a 15 millimeter square. Let's make this solid. I keep trying to drive by using the screen that's on a slight delay, which is really disorienting. I should use the one that's on the HDMI splitter. Yeah, it's easier to use that one. So yeah, this height is 0.15 millimeters, this is 0.3 millimeters, etc. So as it prints, each one of these just adds exactly one more layer. So it's actually pretty nice. Even the really thin layers, Like, I'm sure a lot of this is, a lot of this would be different printing right up against the bed versus printing something that's like a bridge. So it might be worth another test to try maybe, you know, like a very small, like maybe 5mm, like hollow box basically, and then see how flexible the top layer of that box is. Because that's probably a little more like the structures I'm going to be printing for this button pad. So this material has a lot of jobs. It needs to be flexible because that's kind of my goal for this whole project, is it needs to conform to the shape of the object I stick it to, which in this case is round. And I plan on embedding magnets in it, so it's important to have a thickness of this material where it's thin enough that the magnets are nice and strong, but thick enough that that the material is strong enough to stand up to the magnets. And well, so on the back of the enclosure, I'm going to care about kind of creating the right shape pocket for the circuits and creating a strong enough and you know, kind of, I think I care about creating a pocket for the magnets that holds the magnet snugly, is the right distance from the surface it's trying to attract, and I need to make sure that the material around the magnets is just generally sturdy enough for the forces that they're going to undergo. The top side is going to be a little harder because on the top side I actually care about a couple of conflicting goals for the buttons. I want the surface of the button to feel like a fairly rigid object. So I want the button itself to be fairly high infill, or to at least have a lot of kind of support struts in it. And I want the top to have a unique texture that I can define kind of per row. But despite the button itself moving as a fairly rigid object, I want it to be mechanically decoupled from all the buttons around it. So I think the best way to do that is probably to have a structure that incorporates some kind of curve or like a fold, so that when I press the button, that fold or curve can straighten out to give the material some room to flex in that direction. I mean, otherwise, because this material is so flexible, the buttons will still be pressable, they just won't feel as good. They won't really feel like a button moving, they'll just feel like there's a button that stays still and then there's a lump in the button that you kind of have to press, and that won't feel so good. And one way to avoid that for sure is to use separate keycaps. But one of the little challenges I set aside for myself in this project was to see if I could make it print in just two pieces, just a top and a bottom half. So it's pretty nice material. I was testing this with magnets on my whiteboard earlier today. Let me see if there's a small thing I can use in front of the camera. Oh, that's right. This is magnetic. I should just take the glass off of this. Okay. Yeah. So I would probably be using not 3 of those, but just 1 of those. So what size are these? I think they're 5mm by 1.5mm. Let's try to check that. 6mm diameter by about a little under 1.5mm thick. So if we start with the very thinnest material, let's get a better close-up camera angle. Servo. Let's do some manual focus here. That'll tell me where the camera is kind of close enough. Oh yeah, I'm still not a little behind on chat, but I saw out of the corner of my eye some comments about the Space Mouse, and it's a relatively recent thing. Like, I've done plenty of CAD before getting it, but it's so nice. It makes things much faster, and it's nice for video too, because you can basically like be a videographer with one hand and get things done with the other hand if you can multitask like that. Oh, I love how this stuff looks. This is the Water Clear Ninja Flex, which makes, I've seen it used for a lot of different things. I think I've got something, I've got that little synthesizer case. Maybe you look at it at the same scale. So, let's see, so this was printed, you know, in this orientation, I think. So all of this was on support material that I trimmed away. I think those are the lines left over from it. And then, yeah, I think I had set this up for very, very sparse support material, so it was pretty easy to clean out. Anyway, doing this one in one piece was really challenging, and I don't see a good reason to make... I mean, I think that it wouldn't give me a good result to try to do this project in one piece because the flex circuit is so thin that I wouldn't have any way of propping up the opening while it's printing. So for this project, I just plan on printing the two halves separately and then using some kind of flexible adhesive like E6000 to glue it all together. Or maybe, I also thought about maybe making it so that I could heat stake it together, which could end up, because I'm a little worried about the glue being, you know, both eliminating, blah. I'm worried about the glue both limiting its flexibility and causing the flexibility to be non-uniform, which could feel kind of gross. Let's try the autofocus again. All right, so this is one of my magnets, and this is just painted steel, which is probably a pretty good approximation for my whiteboard or one of these lighting poles or anything else that you might want to stick this to. So if I start with the thinnest layer over here, that's pretty good hold, but I kind of worry about how much that's prone to tug at the material. And then, you know, I think 2 layers is probably safe. Any more than that, like 3, like that feels nice and rigid, but I can also tell the magnet's getting a little weaker. So 2 layers might be the best compromise, and then just have a nice snug fit circumferentially around the magnet. But yeah, that does feel a bit sturdier with 3 layers. And then here the magnet's just kind of getting uselessly weak. And then, yeah. Like that kind of works, but I wouldn't feel like I'm really getting my magnet's worth at that point. So that's one test. We'll probably also want to print another test for the button shape. So I think that's what's worth designing next, just so that I can get that test print going. Like that should be a quick test print, and I can just do some of the other design while that's printing. So for the buttons, I don't know, it might be faster to just try modeling something than to describe it, because, you know, that's how it works sometimes. And then I can describe it afterwards if it looks like it's working. Yeah, I mean, one concern that I have with this, I guess, is I guess I'm worried about, like, when the layers flex, I don't think it would feel good at all if these brass nubs ended up coming out of some kind of little pocket in the button keycaps. Like, if that happened, I think that would just be kind of annoying. So I think I want to avoid having, like, well, I don't know. So either I need something that's like very form-fitting around the button so that that wouldn't happen. So something that grips the bottom of the button pretty well, and then uses that to position itself around that brass button. So that might work well. Or something where whatever's pushing that brass button doesn't really conform to it tightly, but has like a shallow like a kind of gradual curve to it, so there wouldn't be a ridge for you to hit if it does kind of bend out of place. But I suspect that a lot of this is also going to be constrained by how I want to try to design the buttons to have a good, like, rigid feel to them, as a unit. So, like, you can tell this stuff is super flexible. It'll take some internal structure to make something that feels more like a button out of this. And I tried to do that with, on this synthesizer case. You can't really see it right now. I think I still have some separate models handy. Yeah, the internals for that synthesizer case look kind of like this. This is an earlier test print. So it's kind of like a Lego. And I think this is NinjaFlex. I printed some of the tests out of SemiFlex, but that was much too stiff. And so the NinjaFlex is very flexible when you print it thin, but it's easy to make it considerably more rigid by adding some structure. Let's see if I can get a view of how this button moves, because I think there are some aspects of this design that didn't work out too well, but at least in isolation, without the whole thing assembled, it looks like it should work, which makes it an okay demo, I guess. Oh, I need to put a lighter. Ooh. I keep saying I need to fix up that bearing. Cat. Yeah, that kind of works. Let's see if any of these prototypes were different. It also might be easier to show one of the little ones. Because, like, this is like a full-size pad that I made before making the kind of form-fitting enclosure one. I think this one was the best demo. What is up with my autofocus? I guess it was just a very blurry scene. Alright. Maybe some more light. Oh, that light is really harsh. Okay. So my goal with this was that with these two separate sort of thin layers and the kind of boxy shape of each individual button, that I wanted each button to feel like a fairly rigid unit, but that the button itself should be able to move in a way that kind of keeps it planar with the other buttons, keeps it parallel. So I think we can test how effective this design was by pressing it in different locations and looking at how it responds. I think I still need to get a better angle on it though. Oh, I can move the camera lower on this pole. Let's do that. Oh yeah, it's okay, Tuco. Sorry about the motion. Where is my focus? There's kind of an art to putting the camera a little bit higher than you actually want it, assuming that the mount will settle slightly. I think that focus is probably fine. Oh yeah, this is the one that I printed out of Semiflex, and it's actually way too rigid. Like, it just feels like you can tell that it's more flexible than plain old PLA, but it's like not nearly flexible enough for moving parts. So all of the rest of these I've been printing out of a regular NinjaFlex. So here's the test with the individual layers. And I think we wanted the magnet probably on 2 or 3 layers. And so it's a little hard to tell how effective it is. It feels good, but it's, you know, like, it also feels like it would be better if, like, I think one of the flaws with this design is that it's expecting these side pieces to stretch, whereas I think what I really want is not stretching, but just kind of curling. Because this material doesn't stretch super easily, but it bends really, really well. So if I can take advantage of the bending rather than the stretching, then I think I can make buttons that actually have a nice feel to them. So yeah, I mean, that kind of seems to work. I mean, and the idea is you would have enough of this support, of these little support struts across your entire pad of buttons that it would keep the surrounding area spaced off of your tactile switches enough. Okay, let's just go to CAD and see what we can come up with. I think we can do better than that. That was the old design. That's old and busted. Okay. So, trying to catch up on chat very slightly. Cool. Let's see then. This was our test. Let's go back to our full-size CAD file. Okay, so that was the milling outline. I think that's what we were exporting here last. This bunch of guides for stuff. That's our actual circuit outline. I don't think I care at all about this outline anymore. I need to start version controlling this file. Ha ha ha. And it would, well, stick this on a garbage layer. buttons, teensy, references. Okay, so I think it makes sense to start with a design around this button with Z set to the bottom edge of the button, since I think that should be flush with the the surface mount pins, at least enough for these purposes. And then we can just try prototyping something that sits on top of that. I think I do want to move this into place on the circuit board so I can at least make a like a support for the button that takes into account the placement of the pins for the tactile switch and the resistors here. So, I mean, I could do something fancy with like object instances, but right now I'm just going to move one of these to an arbitrary place. It's easy to work with. Alright. Oh, I kind of don't like these things. What are they on? Alright. Alright, let's delete all but one of these. It'll be easy to make. I mean, not all the buttons will be the same. That's like one of the things that I want to use. I want to use the advantage of 3D printing to make it easy to pattern these buttons, but I want to start with a template that I can test on its own first. So, one decision to make here. Well, so a quick note on the coordinate system. I am going to assume that the flat flex extends below the XY plane here. So I want to assume the flat flex extends below the XY plane here. And I don't necessarily care how thick it is right now. I will when I'm designing the bottom half of this case. But for now, I'm just going to assume that whatever I'm making sits on top of the flat flex, and that the flat flex and the bottom case create a pretty much flush surface. And so that'll probably be the easiest way to do this at the moment. I can adjust that later if I need to. But that means that I can make little prototype doodads that I can just sit on top of here to test. So I think earlier I had decided that this would be a good size for the actual kind of the feely part of the keycap. I think I buy that. The other dimension to figure out is the thickness we need between the top of this button and the actual surface we're going to be feeling. And that might also be something we can test using this little test print. Since this is a piece that we know the thickness of, I can just try to see how different layers of this, and I can even fold this and use multiple pieces to see how that feels. And because I mean I want some kind of structure, of course, that's going to distribute the force as well as I can, but the most I can do to prevent indentation on that very middle is to just have a solid fill. So I want to see how much of that it takes for it to actually feel like it isn't just a little, I don't want it to feel like the button is so small, I guess. I want it to have a more pleasing surface area. So this will be easier if I cut this, actually. So thin at the end. This is, it's like 14 layers. And, ooh, that's feeling much better. I mean, if I'm like pressing on it, I can kind of feel that there's something clicky in the very middle, but it's a lot less offensive. I think I might want something a little bit thicker still. Although it occurs to me that I probably will be making it thicker with the addition of textures on the top. So this is actually not a bad baseline thickness to just start with for the model. And we're going to test this in isolation anyway to see what it's like. So that's like 2.2 millimeters. I mean, I could calculate what it was exactly, but I don't really care because I think just making that about 2.5 millimeters is probably a good start. So, how high is that? If we start there, okay. Go up 2.5 millimeters. Where did that line go? Let's do it here. Vertical line. Let's turn off some of these other snap points. No? Why can't I get the center of this object? Maybe that isn't a circle. Okay, fine. Let's do this. Should make an axis through the button. And then move it vertically. Okay. I don't know why I bothered making that line. Let's just put a point at the end. And let's go up by 2.5 millimeters. All right. That's a good chunk of material. So that's what I want. That's like about the minimum that I want between this hard nubby thing and wherever I'm likely to be contacting it. So, I want this to have kind of a scoop shape, which I'll then kind of further modify based on, after I duplicate these over the surface. But I think for now I want to use that as a guide for truncating this down. So, what do I want this to be like? Sure. Yeah, 2.5 millimeters. So let's start with that. And let's make that not a razor sharp edge to start with. That's way too big. I forget how big a millimeter is at this scale. Let's try 1 millimeter, not 2 millimeters. No, let's try a 1/4 millimeter. That's more what I want for now. Okay, so I'm going to start by taking out the area that I know needs to be gone. I haven't quite decided what the interface between the button and the underlying tactile switch is going to look like, because there are a couple of options. But I can start out by just removing the stuff that I know needs to go. So actually, I should remind myself how much travel these switches have. .2 millimeters of travel when you click them. So we should make a plane to describe that. So let's just stick this somewhere. So oops. 0.2 millimeters down is right there. Now the other level I'm interested in, let's hide that for the moment, is the surface of the button and then 0.2 millimeters up from that, because that's where we're going to need to have this clear. So let's not cut it super close. Let's leave actually, because we want there to be enough room for the NinjaFlex to deform here. If it was a rigid plastic button, then we could just deal with just a little bit over 0.2. It wouldn't be a big deal. But in this case, I would actually expect the button to well, let's start with 0.2. Where does that go? That gets us about that far up the plunger. I guess this is another reason to kind of scoop out some material like around here in the interior of the button so that when it deforms downward, that material doesn't end up impacting the top surface of the tactile switch. So the other issue here is printability for sure. That might end up being one of the main concerns actually. Because getting that other design I had on camera, getting that to print was kind of tricky. Yeah, I forget how that printed. Oh, right. It was printed upside down. Yeah, so my solution with that synthesizer project was, because I had so much structure underneath the buttons, I printed it with the button face down. So I couldn't really do much with the button faces, other than very simple textures that took a couple of layers. But I think I want nicer 3D shapes for the buttons here, so I might need to just compromise on the underneath here. So what this will look like from the 3D printer as soon as I start carving pieces of this out is, it'll start encountering gaps that it has to bridge over. So then I just need to pay attention to the shapes of those gaps and make sure that it's something that can be bridged without introducing artifacts that'll be a problem. So for example, I couldn't have a shape in the middle that's just like a kind of a scoop downward that just takes out a bunch of material around the edges and leaves more in the middle, unless I also had kind of some webbing in there to support that as it got printed from the bottom up. So, and I'm still thinking also about just how much I care about the button kind of slipping against that that bottom piece. But I don't think I can really print super fancy structures to prevent that anyway. So, yeah, I think that means that this has to be relatively straight across. I mean, I might be able to modify that design later with some additional kind of crossways pieces that can act as supports as it prints. But I think right now it might be simplest just to position this so like right now this plane is at 0.2 millimeters above the surface of the button. So that's like ideal. Like I definitely need to cut away that much material even if everything was perfectly rigid, but it's not, it's really flexible. So I actually want to probably cut away, you know, as much as I can tolerate without this kind of, so I mean I could actually make that completely flat, for example, and that might be fine. But I could also get a little bit of additional rigidity. In the exchange, the compromise here is more material gives me more rigidity and makes it less likely to flex, but then it also means that when it does flex, it's closer to hitting this. So I think I'm just going to kind of pick something that seems like a compromise by eyeball and then test it. So then, as far as how much of this material to remove, I want to use as much of this for support, both in printing and in actuating the button as I can. But this part of the button actually needs to be pretty much free-floating, so let's cut this off, and then, yeah, I'm getting ahead of myself. We need some support, but this part of the button needs to float freely, so I think there's no getting away from just chopping off that bottom part. So, chop that, and let's also just subtract this button tip to leave an indentation for where that goes. So now, even if we hide the actual tactile switch, we'll see that, which this is something the printer should have no problem bridging over. And I'm uncertain as to how that'll actually feel, but that's one of the things that I want to test. So then, the next thing I want, so I don't necessarily want the button itself to be this thick, because that'll be prone to kind of breaking. It'll be like this big thing that I'll tend to want to pick at. It's like a pencil eraser. So I want the surface to actually be more up there. But I want to use some of this space both to provide some rigidity for the area surrounding the buttons and to give me kind of a little bendy thing that I can use to support the buttons while also giving them the ability to move downward without having to stretch the material. So for that, I want something that, that doesn't go straight across, that has like a curve in it, for example. But I also need to pay attention to printability here. Let's think about how this is going to have to be supported. I mean, one option here, since I need to support this whole thing somehow, is to basically just have to build up a curve like this. So have kind of a thin-walled flexible bit of material that builds at an angle here, so that when you push this button down, that bit of material can buckle, or even just flex just a little bit to allow this to make, good contact with the center. Disadvantage of just doing that is that then that doesn't solve the problem of how I want the kind of facade of this to be up here. But in order for this to be flexible as it wraps, I actually don't want there to be a lot of interconnection around, that's far from this axis. So it's actually good to keep the material that actually connects to the base around that axis. And then I can have something that goes up in here and surrounds the button perhaps, but isn't necessarily connected to the button, so they can just, kind of slide next to each other. I like that so far. Let's see how that looks. Let's think about the thickness of this material, maybe. I think I want that to be maybe like... I don't want to necessarily make that too weak, because that does have to hold the button such that it feels kind of rigid, but then it needs to be weak enough to buckle when you press it. So I think this also might depend on how much space I actually have around these buttons, but I actually have quite a lot. So maybe it's less limited by that and more limited by like the overhang angle I want to have. So let's make some references. I want something that's like a line between these two. And even this is like a steep enough overhang that I don't know if I can do that. Let's try that. And maybe make this 0.75 millimeters thick. That is not tangent. What is that? All right, that's fine. This actually, I hate dealing with hollow curves. These should really be curves. Oh, that's right. topology derp. I should loft these separately and then do the Boolean in 3D. I mean, I could also do this with like some kind of cone thing, but I like the loft tool. Boolean not work? I think that Boolean worked. What is that? Oh, that's a leftover chunk. Okay. That's going to be a huge printability problem. Like that bump. And I don't think it's actually necessary. So let's just get rid of that. Great. I mean, this is a large bridge, but at least it's straight across, which is something that has a hope of working. But that's definitely going to need testing. That's got printing problem written all over it. And this, I think, is going to end up getting merged with some other structure, but I want to be sure to leave enough of it flexible. This also might need a cutout for the resistor. Yeah, the resistor goes over there usually. Okay. I think I might do symmetrical cutouts so that it doesn't make it feel lopsided. The resistor placement also isn't exactly the same everywhere. Yeah, I kind of want there to be more. I mean, right now the button itself is solid, which is probably necessary. I mean, it'll print with infill, but like I need to make a lot of this fairly flexible, but then some of it more rigid. I'm also just thinking about like how much material I can afford to have in the space between buttons. More than that. Maybe a 20 millimeter test square, but that's too small. So, okay, back to this thickness sample. How much thickness can I tolerate here? Maybe 5 layers? What is that? .75 millimeters? It's a nice size. What does that actually look like? It's just that. It's not much, is it? So that's starting on the same Z level that the switch is at the top of the circuit board. And so that'll kind of merge with this. The interior and that'll be hollow. Yeah. Just looking at the resistors. Well, let's move this over to the other button. Figure out what kind of symmetry it should have. Oh, I should also think about how thick this pocket for the resistors needs to be. These are just 0603 resistors. These 0603 resistors, in fact. So I don't need to leave much space for them, but they will take a little bit of room. trees are down. Oh, these are the worst tweezers. I can't use these for 0603s. Half a millimeter should do it. I'm measuring 0.45. I don't want to leave like a super oversized pocket for them, but I probably want to leave enough for a little bit of a solder blob if that happens now and again. So something like that. Is that my extrusion? Oh, well, that's fine. 0.45. That seems tolerable. And yeah, sure. I just want some cutouts like this on the other side because these will make the button a little bit weaker right where that is. So I want that to be balanced a little bit. These are a little oversized in that direction, but my circuit or my placement of those resistors wasn't super consistent from button to button, so it seems prudent. So start to assemble this. I want to connect this sheet. Well, let's first attach these to each other. And then let's use that to cut a hole in the sheet. Delete the middle. Attach these two, not those two. And then cut out. Okay. So these will be little bridges, which is fine. And then this will build a little overhang. Big bridges, which we'll have to make sure that works. Oh, I need to leave a little bit more space for the plunger on this button. Okay, that seems like an okay way to do it. And so a lot of this material here is kind of unnecessary. It's just kind of hard to avoid with the 3D printer building in this direction. The other thing I think I want to do in this particular test is I want to try building like a surrounding around this, like some kind of facade that doesn't look quite so chunky in the Z direction. But I want that to be fairly fairly sparse. Comfortable cat. Oh, he's so warm. All right. As far as clearance, yeah. Let's take these two circles. And project them. It's 0.826 millimeters. I was thinking about whether that would be enough of a gap if I just started building a surrounding that came up to about that same distance. I think I want to stay clear of this part if I can, though. I mean, really, I guess some of this is about what distance do I think I need between two pieces that I don't want to stick to each other. And that's probably pretty small, like, I don't know, 0.5 millimeter? What did I use here? Well, maybe 1 millimeter. I mean, I've got moving parts here that are like 0.6 millimeters apart, but they look kind of close for NinjaFlex. So let's see what that looks like at an entire millimeter. So and I do want the buttons to stick up a little bit. So let's bring that down. What does 1 millimeter look like? Whoops. That's the opposite of what I wanted. I think that's maybe twice too much. I mean, these buttons don't travel that far. I mean, you probably have to press this a little more than you would have to press the plunger because this material is going to deform. Yeah, let's see what that looks like. And let's project. Something like that. All right. And then I want this to be pretty much as sparse as I can make it. This is going to need a support of some kind. And I probably want to angle it some to avoid this wall if I can. Gotta remember to save this just in case, something terrible happens, like it crashes. Let's do a circle. We should really get a new working plane for this. Is that what I wanted? Oh, I was just getting confused, I think, because this plane doesn't take effect in the other viewports. I was trying to check that it was actually lined up in a different viewport, but anyway, if I just rotate around this, it's easy to tell that I did that correctly. So the plane we're working on is now the top surface of this sheet here. And I can project stuff down to that plane. Let's leave a millimeter, maybe. Cool. This has a bit of a curve because I needed to keep it away from the base of the button, but I didn't want much because I want this to be pretty strong. Let's hide some of this stuff. Okay, so that's basically what we would see from the exterior. There's kind of a cavity in here where there's some room for it to kind of squish a little bit, but then it doesn't seem that thick from the outside. But then I want this to be largely hollow so that it can bend, and like these areas can just kind of collapse and kind of just change shape a little bit as it bends around different surfaces. So we'll need some more support. I think I'm just going to put in some sort of radial fins for now. Maybe I'll make a copy of this on another layer. So I think I like the hexagon, but I don't want this to be axis aligned. Turn it to be like that. So it's slightly harder to work with, but it should look a little nicer. So Boolean onion. Okay. Turn off some of this stuff. All right. I think also to make this a somewhat more valid test, I want to print solid blocks around the edges to give this something, because like this part's going to be very, very flimsy, and I want to test how flimsy it is. But I want the edges to kind of stand in as something arbitrarily solid. get a copy of that for later. It should be easy to cut out this other stuff if I want to, though. These leftover parts. I don't think I necessarily want to close in all of these chambers. I don't know, maybe it's just harder for that to union this all at once. Let's try unioning this gradually. Okay, I think that worked better. Oh. I guess I should just subtract those. Objects don't intersect. Okay, well, maybe I will see if I can print these without unioning them. I think Kira can deal with that, because I don't need this long term, I just want this for one print. And so I don't want to have to solve a topology riddle right now. So there's the frame, and there's the interior. I think I'm just going to try to stick those both in one STL file and let Kira chew on it. Okay. Load. Huh. Where did that export? Put this maybe closer to the camera and also in an area that I didn't print in last, so I don't have to re-clean the bed. So I've already got this set to NinjaFlex, all the same settings as that previous test. This says it'll take an hour. So it's doing something weird at the boundaries between those. Okay, maybe I should actually union these. I don't think this is handling it properly. Alright, fine. I mean, I could change the topology of this a little bit to avoid having to solve a riddle by basically making a couple of cutouts in this. I think that might be the easiest thing to do. Okay, so this will definitely break up the rigidity as well, which actually might be kind of nice for some of these tests. Let's at least print the bottom solid. Let's make that thicker. I think I want that to be thicker. Okay, let's temporarily hide this. All right. That seems like an okay test structure to use. So let's try combining that with this. Huh. Oh, I guess that also formed a closed. All right, I guess I just need more of these little openings in my thing. Okay, that should be more than enough. I just want these to be kind of consistent because I don't want that to affect the uniformity of this test too much. Hand wavy answer. All right. Let's just like delete a bunch of that. All right, more cutouts. Okay. Can't tell whether that's actually like closed in or whether that's just a shading weirdness. Okay, yeah, this part includes all those openings. So that seems right. Kira. Huh. Well, that's interesting. I wonder if there's a small gap right there. The, yeah, the bottom layers look better, with the exception of that. Let's take a closer look at that geometry. Oh, what is going on there? I think this might have been a result of doing some operation with too high tolerance. Or maybe it's just not, because it looks like this might have eaten one of my edges that I kind of wanted. That's annoying. Let's go back a couple of steps. Okay, let's do this a little differently. That's not quite what I wanted either. This whole thing is a test jig. Let me not worry too much about the edges here, because a lot of that's going to have to change to attach to to the other buttons and the rest of the structure anyway. So let's do something simple. I'm also just slightly annoyed that it's, that, I hit problems with shapes that have like hollow bits inside. Feels better to have the layers cleaned up. Okay. So I want this, the outer frame here, and these inner struts. And I think I just want to get rid of everything else, which is a bunch of guide curves and stuff. And so try to just join these together without making any concessions to the topology first, and see how that goes. could have failed for any number of reasons. Still failed. It's fine. Let's try nudging this inward a little bit so that it overlaps slightly. Pray to the Boolean onion, make a sacrifice. There we go. Now let's get these fins truncated. Great, and that's the piece I want to keep. I think that's just everything. Okay. I think that's a better shape. I think I no longer have terrible problems with the corners and the shape. Let's redo that. Curva. I have beer. Someone's asking in chat whether this Rhino program is not capable of extruding a sketch. Sure, it can extrude sketches. It can do a lot of different things. I just usually, there are so many different ways of making something that, it's easy to just kind of do whatever kind of pops into your head first. Did I clear this? Alright, NinjaFlex. I don't think I need a brim. NinjaFlex is pretty sticky. Alright, this seems like much better geometry. So I've got room for the tactile switch and the resistor and symmetrical resistor hollows on the other sides. And then bridging that, I start building this structure for holding up the roof. And I have a fairly solid button. I want to turn what happens to the settings if I change strength to high? I mean, I can go in and like set the number of shells and all that if I care, but. I think those defaults might actually be what I want. It's, yeah, fill distance of 1 millimeter, which gives the areas that I want to be sturdy should be fairly sturdy without being just like overly dense, such that they end up oozing. So yeah, I'm gonna try this test print. We can sit it on top of a tactile switch and see how that feels. Let's see if I can send it directly to the printer. This doesn't always work, but. It says it's uploading. Yeah, Cura does not seem like it actually is very good at uploading directly to my printer for whatever reason, but that's fine. I'll just send it to Octoprint. Great. So now we have some time to do some more CAD while that prints out. I'm also going to pet my cat and drink my beer and check the chat, since those are all things I could do. Well, there's a lot of talk in chat about different CAD programs. I've used a bunch of different programs. I mean, I started out modeling things totally just for, for animation, basically. The first program I used is probably one that not a lot of you have heard of. It was Caligari TrueSpace. And I started out with it because I could afford it. It was like I could save up my pennies, and it was like a professional animation tool that you could buy for $99 for the student edition, so that's what I had. That was after many attempts to make my own. I had some wireframe thing that I wrote in C ages ago. But I've used Blender a lot. I like Blender for a bunch of things. It was probably my kind of go-to CAD package for modeling just like random stuff before I kind of fell in love with Rhino. And I've used SolidWorks some, I've used Fusion 360 some. I really like parametric CAD modeling for certain types of projects. I don't like it as much for just experimenting when I don't quite know what I want. I mean, it kind of depends on what sort of experiments they are. If they're the kind of experiments where, I don't know what size this part has to be or how big these gears have to be, then SolidWorks can facilitate those experiments really well. But I like Rhino for experiments where it's more like, oh, I want to write a program to place things on a plane kind of weirdly and see how it works out. And Rhino gives you interesting tools for doing those kinds of experiments. But Rhino definitely has more weaknesses when it comes to like design history. I mean, Fusion 360 has really nice like kind of infinite history that gives you the ability to avoid losing work pretty effectively. And most parametric CAD packages have something like that. Rhino has something kind of like that that's not nearly as pervasive. It has this optional feature where you can have operations that support this feature can save history in addition to doing their operation immediately, and then you can go back and edit them. And it works really effectively for some operations, like lofting. You can easily go back and change the parameters. But it's not really a total solution, and Rhino makes compromises so that you can always just kind of go in and like do whatever you want to the model, regardless of how it's internally structured, because it tries to avoid having much structure. So it's a little bit like the difference between I see Rhino as kind of like making a document in Inkscape, where you're like putting all the paragraphs in the right place, whereas like SolidWorks is more like LaTeX, where you're operating on your document at a very high level and you can change things very easily. But it's harder to get just a very specific look. It's harder to kind of prototype things using that kind of LaTeX approach. You'd have to like write a class to do that, write a package. So yeah, different kind of tools. I think Rhino has a pretty big following among like architects and jewelry designers. I kind of heard about it from other people who do like interactive art installation-y kind of stuff, which is, why I thought it was worth spending the money on for my workflow. But yeah, it's definitely not for everyone. It's just one that I happen to like and be fairly familiar with. Oh, yeah. I'm also noticing a comment in chat about making that a curved shape instead of a cone for that inner wall. That's probably a really good idea, since, yeah, the cone might be too strong. Right now, I'm more worried about it being too weak. I'm worried about it not being printable. But if this print works fine and it does turn out to be too strong, then I'll definitely try kind of bowing that out so that it has a nice weak area to press down on. I also might not have to worry about printability that much, because as long as the base is sturdy, NinjaFlex is very sticky, so it'll stick to itself quite nicely. Oh, I'm also noticing on chat that TrueSpace is free now. The company went under and released the source code. I'll have to catch up on, or I'll have to check that out. Yeah, I never got around to trying Lightwave. I think Lightwave was a competitor to TrueSpace at the time, but it was a little more expensive. I remember when features like spherical texture mapping and keyframe animation were new. It was a really big deal when they started putting navigational elements in the 3D scene instead of having everything be on toolbars. Oh, I also noticed a question about the 3D printer. This is a Type A Series 1. It's from the first generation that they made out of metal, so it's not the plywood Series 1, but it's not the Series 1 Pro. It's in between those two. So it doesn't have a heated bed, but my bed is a warmed bed. I have like a foot warming mat underneath it that actually gives it enough, like that plus that yellow surface is a PEI plastic. So that plus the little bit of heat and the enclosed space actually helps it adhere reasonably well. Such a peaceful cat. Oh, yeah, from U.S. Water Rockets, they knew that I had the Type A, but I had some problems with the gantry wiring. It wasn't so much an upgrade. Well, it was an upgrade, but it wasn't like something I had to do from scratch. It was like they issued an upgrade. I think the original version of this had just like a bunch of stranded wires and a ribbon cable. Yeah, I think the main wiring harness between the hot end and the gantry was like a fine pitch ribbon cable, like the old style 80 conductor hard disks, and that was prone to failure. So, and they have good tech support. They send out spare parts, and it's pretty easy to get stuff fixed. It doesn't take long. But then they just sent me an upgrade to the not just the cable itself, but the boards on either end, so that they could replace the cable itself with a flat plex. And that seems like it's pretty good. It's also a consumable part. You have to replace it occasionally, but it seems to last a lot longer. I've also tried to kind of put Kapton tape in the right places to anchor it and keep it from rubbing. The problems I had were pretty weird. When that ribbon cable would start to go, I would end up just losing steps on that stepper motor because, the most sensitive thing. I guess the heater was sharing a bunch of wires in the ribbon cable, but I don't know how many wires they used for the stepper motor, but probably a lot fewer than for the heater, and so it probably showed the failures first. Oh, and yeah, if another question, if I had it to do over, would I still get the Type A? I don't know. I'm pretty happy with the Type A. I don't know if it was, there are probably other printers that would have cost a little bit less and given me similar performance. It's probably a pretty, if I were looking at other printers, I think some of the new Lulzbot printers are pretty awesome, and I am missing a couple of features on here that some of the newer printers have. Like, this doesn't have auto bed leveling. The bed leveling is totally manual. It's annoying sometimes, but I have the printer in a really controlled environment right now, so I don't really have to re-level it much. But yeah, it's mostly, it's mechanically a pretty easy thing to do. It's just turning bolts, but it's the sort of thing where you have to kind of print a brim around your object and tune it carefully, and so it's one of the annoyances. I did upgrade the plate from just bare glass to PEI, which seems to help a lot. I do miss having a heated bed, but their heated bed upgrade is kind of expensive, and I don't know if it's worth it, so far I've got my foot warmer under there. But yeah, there's a bunch of good printers. I think I'm glad I went with this extruder instead of a Bowden drive like the Ultimaker, because this extruder has been just such a workhorse, and it's been really easy to clean when anything messes up, and it handles Ninjaflex really beautifully, so I do like the extruder design. I think I modified it very slightly by adding a heatsink, because the cold side of the extruder wasn't staying as cold as maybe it could have, so. And I've had to replace the fans a couple times, stuff like that. I replaced the hot end once. So, stuff eventually needs replacement. I think I've had to replace maybe one or two of the stepper drivers. Oh, I had a really weird problem with it was actually the microcontroller in the board that actually drives the steppers. I think it uses a ramps board or something like that. That's basically an Arduino. And the actual ATmega microcontroller on that blew somehow. Because I had this whole sequence of problems that I think was related to when the ribbon cable on my machine was starting to go out. I think I had some kind of failure that caused the 24-volt power for the heater to end up on the Arduino board. And I don't know how it made it all the way to the actual MCU, but the MCU itself was fried. And so I was in the middle of some project where I needed to print lots of stuff, and I was kind of panicking. And I had the printer open and was diagnosing it, and was talking to tech support, and I had pretty much traced it down to that board, but I didn't have any spare of that particular board. But I did have some other Arduino that had the same MCU on it, so I got out the hot air gun and desoldered that chip and put it on the board in my. I think that's still the board in my 3D printer. I think tech support sent me a replacement board, but I don't think I've had to use it yet. I think the board that I did the SMD rework on is still running. So that was kind of funny. Yeah, it's been a real workhorse. I like Octoprint. I've upgraded the Octoprint image on there myself, but I appreciate that it shipped with Octoprint. Yeah, really my only The only thing that kind of nags at me about it is that I do still wish it had a heated bed, but the combination of the somewhat warm closet and the foot warming mat underneath it seems to do pretty well for PLA at least. And for ABS, I have another smaller printer. It's it's an Orion Delta with a heated bed. So with that one I can print ABS. I just can't print such large components with that one, and it's not quite as accurate. Yeah, just to confirm from chat, yeah, the main board is, I think it is an Arduino Ramps board. It has the little plug-in Pololu style stepper drivers. So that was the one that I had to do the hot air replacement on. And then, yeah, the Octoprint server is running on a BeagleBone Black, which is really nice. Oh, I also had problems with the Wi-Fi, weirdly enough. So the BeagleBone doesn't have onboard Wi-Fi, but it has like a little USB Wi-Fi dongle plugged into an onboard USB hub. And I had that thing blow out like twice. I don't know what happened there. But like I would just lose communication with the printer over Wi-Fi, and then I would just need to get something done, so I would plug in Ethernet and it would work. And then I would go back and debug, well, why isn't it working? And it was actually the physical Wi-Fi dongle in there, and I would replace it, and then the Wi-Fi would be working again. So I don't know what's up with that. Whether some kind of electrical event was causing that, or whether they were just bad Wi-Fi dongles. I mean, I don't think the one I replaced it with was exactly the same kind. I just picked something else I had handy that fit the same connectors. I should clarify that I use this printer a lot, so, I mean, I don't know, I've had a bunch of things need replacement, but I've also, like I've had months where this thing was pretty much printing continuously, and I think that's pretty normal for most 3D printers these days. I mean, that Orion Delta has been remarkably low maintenance, but the other machines I've had have all occasionally needed tweaking, needed parts replaced like this. Get a bit of a head start on the CAD, maybe. Although, I have to say, it is kind of nice just streaming and just like watching the machine print and drinking beer and petting the cat. Like, that's a pretty relaxing stream, I have to say. The large print volume was super useful for some of the projects I did with it. I don't know, I printed a bunch of the pieces for that. I keep describing it as this art piece that I kind of don't like anymore, but I need to fix that. I made this thing that is quite elaborate and probably unnecessarily so, but it involved a bunch of 3D printed pieces that created a pretty large structure. Yeah, I think the new TAS, whichever the new TAS is that has the auto leveling and the giant bed, TAS 5 I think. I've seen it on people's YouTube streams and it looks pretty awesome. I think something like that might be my choice if I was buying a new large printer like that right now. Because yeah, I think at the time I got it, it seemed like a good deal compared to the other things that were available, but I think right now it probably wouldn't really make financial sense to get a Series 1 unless, you really needed that particular large build volume. But I think some of the other, like, I don't know off the top of my head what the TAS 5's build volume is, but it's probably similar. I also really wish that more 3D printers were enclosed. I don't know, I kind of solved that problem by putting the printer in the closet. Before I put the printer in the closet, the drafts here were really bad for it. Oh yeah, from chat, US Water Rockets again points out James Bruton's YouTube channel for loads of TAD stuff. Yeah, I've been watching his channel lately. That's potentially why it's been on my mind. It's good advertising for the 3D printer companies. Sure is. But yeah, I was actually thinking about that art project I made that just seemed like it had way too much 3D printing. And then his projects actually kind of make me feel good about that. It's like, oh, well, I didn't print for 100 hours to get a cylinder. But, you know, his stuff works really nicely. I was printing all these really, I mean, a lot of the stuff I printed, I could do it pretty economically. You know, just have little brackets and have, you know, pieces that I then built up other stuff onto and bolted together. But then there were these just giant speaker enclosures. You know, I had this crazy speaker system for this project with 9 little speaker drivers, and they each had their own enclosure. And I wanted it to have some bass, so they actually had some volume. They were fairly tall objects. Oh, another 3D printer from chat that I haven't heard of, the Voodoo Manufacturing. Oh yeah, and also brings up the patent infringement issue with the enclosed 3D printers. And yeah, I had heard about that. And before I moved the Type A into the closet, I had been just sticking some cardboard on the sides, which helped a lot, but the closet's better. It works better than the cardboard. I mean, the combination of the closet and the foot warmer mat under the bed works pretty well. Oh, okay. Clarification from Kenneth in chat that Voodoo Manufacturing isn't a 3D printer, it's a service. I had looked into, there's that service 3D Hubs, and I'm set up on there. I think they recently deactivated my hub because apparently the quality had sunk below their minimum. It's kind of weird. It's like, it seems not like a viable thing to do as just like a random side thing, because like I set it up because it seemed like a good idea to be able to have a way for people to send me print jobs to just print when I have idle print time on my printers, which is nice. And so I did a little bit of that. I got a couple of jobs. You know, customers seemed moderately happy, but it seemed like that's one of those things where you can't really get a lot of work unless you spend a bunch of time just like promoting and doing like kind of customer management and stuff like that I have no energy for. And so if you don't do that, apparently you just can't be good enough to even exist in their system, so they just like disconnected me. I thought it was good for a while, like if somebody wanted to pay me for a 3D print, I could just be like, oh yeah, here's this URL, you can just submit it. I had one person who sent me this like really awful print job that was like, it was like one of those things that just has like, you know, if you're on an FDM printer, there's just no way to support it properly. So I was like in there in Meshmixer adding supports manually and then trimming the supports manually after it printed. And the first time I was like, I really should have charged extra for this, but and then they did it again, and I'm like, okay, I'm charging extra for it this time. And then like it was a successful transaction, but I think they were still kind of underwhelmed with the print quality. And it's like, well, if you give me this weird object that you probably should have just sent to Shapeways, what did you expect? I think I personally really appreciate getting to know the machine and designing for its particular constraints, though. And that's part of why I prefer kind of having my own, you know, preferably inexpensive little machine shop rather than just like sending everything out, because I can get to know the particular machines I have and try to make things that are well suited for their limitations. Yeah, people have unrealistic expectations, and actually, it's making me realize like a lot of the these companies that pop up that are just internet assisted middlemen like Uber and 3D Hubs and like anybody else who isn't really doing any work, just connecting people. They're also usually pushing the worst of the customer service problems off onto the kind of end service providers while taking most of the profits that they can, as much of the profit as they can for themselves. I mean, with 3D Hubs, I would be happy if they just did a better job of trying to manage, expectations for levels of print quality from the machines. Because during sign up, they had me tell them pretty much exactly what hardware and do test prints, and I gave them photos of my test prints, and they were like, "Oh, that looks great." But then the customer is like, "Oh, this is shit." So, to me that's like, well, I could be doing all that extra customer management work myself, or they could be offering that value as part of their service. And I would certainly rather they do the latter, but that certainly makes their thing look less shiny if they can't kind of have that image of being a really high quality print service, even if most of their printers are just at-home models. Oh, there's a question in chat about whether the other mill is just for PCB milling. It's kind of specialized for PCB milling. Like their software makes PCB milling especially easy, and it has the accuracy and build volume that you would want for like a milling machine for PCBs. But it is still like a general purpose machine. The main limitations are the size of the tools you can put in. It only takes 1/8" shank tools, and the size of the actual volume is pretty small. So I think X and Y, it's 5.5 inches by 4.5 inches, and I think the travel in the Z direction is only like an inch or so. So, like, you can do some kind of basic machining with it. So I've done like engraving and making small objects and cutting things out of Corian, and I made some pretty awesome USB memory sticks with it, where I cut 2 halves of a case out of Corian countertop material, and then like engraved stuff in it, and then glued a USB flash stick inside. So it's really nice for kind of really small, like kind of jewelry scale manufacturing, but they definitely specialized it for PCBs. I mean, I think part of the reason I like it is that it hits an interesting niche for me. Like, it's a nice way of doing kind of a variety of different PCB techniques, but also it gives me a small milling machine that works in some other materials I like. So I can cut things out of aluminum and HDPE and Corian and whatever else. Hey Tuco, where are you hanging out? Oh, thinking about the overall shape of this thing too. I mean, I think I'm going to know more once I see how well this test works out, because I'm kind of concerned about the overall thickness. Like, there's a lot of bridging going on, and I don't know what the top surface is going to look like, if it's going to be good at all. And like, I'm just kind of concerned about the overall feel of this thing. But as far as the actual shape, like, I think it's going to be fairly, like, I think it's going to be mostly just an extension of whatever I come up with around the button. So I think it's going to be, I find a good button design, I duplicate that everywhere it needs to go, I kind of trim out all the areas where they would interfere, and then I make, I kind of make a nice surround for that. These thin layers of NinjaFlex, though, are quite nice and stretchy. It's satisfying. Oh, I guess another small test piece another small test piece I could do if I want is potentially something that fits around the Teensy to see if I can get a good grip on its mini USB port. Oh, Yeah, actually the piece around the Teensy could be interesting too from a 3D printing perspective, because I want to get a really good grip on the mini USB port, but I've also got kind of printing overhangs and all that to worry about. I could also try to do something where I try to make the top of the Teensy sit at the same level as the circuit board, but I don't think I actually want to do that. And I think I want the magnets to sit basically at the same level as the circuit board also. Maybe it would be useful to actually place the magnets next, because I want to make sure that there's enough room for those. And that is probably going to determine the overall shape of this thing. Since I suspect, like in order to have all of these magnets horizontally kind of adhere to a curved surface nicely, and also to have the magnets avoid the actual circuit board, I'll probably need magnets kind of over here on the side. So the actual width of the thing is probably going to need to be kind of somewhat wider than this. And I'll have kind of thinner bits on the side that kind of, like little tendrils that have magnets that hold it on. Hey, Tuco. There's a question in chat. Is there a reason I don't make the buttons separate parts? Yeah, I want them all to be one part. I mean, I don't actually want there to be separate pieces that slide against each other. And I mean, I could just have them as separate pieces just for printability and then glue or thermally weld them together. But I'd rather have the challenge of not doing that. I want to see if I can just do this in one piece, and I think it'll work. You're such a tiger. The little cat wants wires. Oh, maybe this would be a good time to do some soldering. To go. I love the way cats smell. What's up, boy? Oh, now it's printing those little support struts, which is cute. Oh yeah, the other mill has a pretty high-speed spindle. I usually run it at like 15,000 RPM or something like that. The higher speeds help, especially for tools like the 1/100th inch, which I use for some of the boards. This is like one of those moments where you just need like the lawn chairs propped up next to the milling machine or the, whatever CNC machine you're watching. The machines used to be kind of out here in the main shop, so it was easier to just pull up a chair, but I mean, now we've got the stream. I mean, you could sit in the closet too. There's like a small stool in there. Tuco, do you want to play Bolt? Such a fast cat. Meow. Aw. likes these things. This button pad would probably look pretty good with LEDs in it. And if it's not wireless, I'd have the power for it. It's a lot more copper unless I use serial LEDs of some sort though. I'll throw a few more bolts for Tuco, but maybe this is a good time to solder some resistors while it's printing. Since I think most of the CAD work that I want to do, I would like to have some answers to questions that this test might help me with. Tuco. Microscope recorder. Aw, Tuco's hanging out over there with all of his bolts on the ground. Alright, most of these resistors are going to be 0603 1.6 ohms. Okay, I think that's the one we want right now. Some sawing going on next door. I kind of like living in a warehouse. There's always somebody cutting into something at 2 in the morning. No, it's usually not that bad though. Oh, the cat's hanging out over here again. You're like, no. What, do you want to fetch more? Tuco, I don't understand. That's cute. Yeah, I think Tuco's looking for more bolts. Oh, these are nice and little. Not gonna cause too much of an issue with the flux being over it, or the rubber over it. So I think I'm gonna try to pipeline this a little bit, or assembly line rather. Tin one pad on each of these, and then put a resistor down, and then go back on the other pad. Ooh. So I've just got to give this a little more heating time when it isn't tinned. Some of these are going better than others. It's usually like a little harder than I expect to make a good thermal connection to this stuff because the copper just kind of sinks away from you due to the flexible nature of the stuff underneath. That one was one of the best yet. I think that's all of them. Really don't want that part shorting out in the middle. The resistors are pretty small once they're attached. Shouldn't affect the flexibility too much, but one reason I added them all in the same orientation here was I wanted to make that, like the narrow axis of this needs to be a little more flexible than the other axis. How's the printer? Ooh, yeah, look at all them prints. Alright, more resistors. I often try to solder cat hair into my projects, but it usually fails on account of it not having the right plating. This white piece of paper definitely highlights the really tiny cat hairs that would otherwise go unnoticed. I think this is the last resistor. Well, the last of these particular kind. I mean, the last of the ones near the buttons. There's one more 1.6K that isn't near the buttons. Yeah. So then this one. Yeah. Alright, one more of these small resistors and then one more big resistor. any of those 47K handy? Yeah, this is it. Oh, it's huge. Huge resistor. Okay, let's go back and solder these properly now that they're attached. Yeah, let's do this with better angles. Oh, 2 goes back. Actually, I could really use a restroom break, but since 2 goes back over here, I'm going to leave you with him. Oh, maybe we need more beer too. Cheers, little cat. Aw. Ah, the little killing machine is licking me. Looks like that's getting close to the point where it's doing the bridge. All right. Soldering time. Maybe some light adjustment. That is way too harsh. Maybe I shouldn't be using these little IKEA lamps unless I really need the harsh light, because it's way harsher than I usually want for this. Oh, that one was off. So, no, that's too dark. I guess I did want it farther away. Yeah, I think that's all right. I had to momentarily check that the recorder was still on. It's such an easy mistake to make. It's like, oh, the lighting's fine, everything else is fine. You're just not saving it to disk. I'm also still not used to thinking of it as disk. I still feel like I'm saying like film or tape or something. Like, I gotta tape that. Gotta get this on film. But it's all gonna go on hard disk. And it's mostly computers recording things or cameras recording things, and then I copy the memory card. But I'm actually surprised at how inexpensive devices are now that record directly, like record uncompressed video directly to an SSD. That seems pretty awesome. I guess I need a lot more hard disk space if I was recording things even in ProRes. Most of my, like the high quality footage that I kind of stockpile to do my edited videos is usually just H.264, just with a kind of high bit rate. And already that's requires a good bit of hard disk storage. That's one relaxed cat. All right, I think that's everything, except for these two. Alright, that'll be alright. Not the prettiest joints. I don't want to necessarily add a bunch of flux to this though, because it's hard to clean out from in between the Kapton layers. So, how's the printer? Still printing, not quite bridging yet. Alright, maybe some multimeter tests. Oh, I saw people in chat asking about what this noise was, but I'm not sure what noise that was. There are a bunch of noises around here, but I couldn't tell you which one that was without actually hearing it, because I think I tuned so many of them out now. Alright, so first I want to look between ground and +5. 24 kiloohms, sounds good. And between ground and the analog input, 37K, which should change when I press any of these buttons. .7. 9.8. Alright. I'm not going to do too much of that with the probes. It looks like that circuit is pretty done. Ready for some code and some 3D enclosure design. Duco, you don't even have your eyes closed. You're just relaxing. Such a cat. All right. Are we gonna have this test done? We've got our circuit. Now we're just waiting on CAD. At least turn off the microscope recorder. Let's see, I'm trying to think of noises that might have been coming through. There's they're probably just people making noises next door. There's a gas heater next to this desk, which is often turning off and on. There's sometimes just like trucks and stuff beeping outside and air compressors starting and stopping. And there's this one noise that I had trouble tracking down. It was like somebody playing a little tune on a horn, and it happened in the morning most of the time. And it turned out to be a taco truck. I think they announced their presence that way. And so when they would drive up to the construction site, a couple, like across the street, they would make that noise to let people know that breakfast was available. All right, what's going on in CAD land? much want to ignore this outer contour. I want to do something with these lines though. Like I might use these to make some kind of profile that I can combine with this top surface. I also probably for modeling's sake want to have the button split off so I can do different things to its top. Did not want to do that without making a copy. These two pieces should go back together pretty cleanly. I think I'm going to want to treat them somewhat separately for these intermediate operations. Okay. Oops. Made a couple of unintended copies there, I think. Yeah. think I do want to, well, I'm going to simplify these a little bit, but I think I can actually just do that with a cylinder cut. I don't really want these to be squares anymore. So this is a piece I'm going to mostly keep, but this is like a keep out area that I'm going to use to trim all the other buttons. So then these are both pieces that I want to duplicate for each of these buttons. Like if I plan on keeping these buttons as separate objects for longer, there are some ways that I can make this less repetitive by making them each block instances. But I'm really close to making these unique from each other, so I don't think that would actually help me at the moment. Alright. Group those together. This part might actually be much easier to do with some kind of script. I don't actually want these to trim themselves. that's the kind of effect I'm actually trying to get. I want these Booleans with their neighbors, but not themselves. And I guess the end result I'm trying to have is to clear out these cylinders, but I can't just subtract them from every button location, because they're actually supposed to be connected in some additional places. That would end up deleting. Yeah, like that would delete this structure in here. Oh, which I could separate yet again. I think all these openings are clear now. Let's actually group those before I hide them. So I kind of want to know if I can Boolean these. I mean, I need to make sure I don't wipe out these resistor cutouts. No. What are the prints doing? It's so bright. I'll take a look at that in person. Oh, it seems almost done, and it actually seems like it looks all right so far. I need to rethink this internal structure a bit because, like, I kind of like how this is, this radiates out from all the buttons. And I can imagine using some kind of, like, Voronoi structure to make something like this. So one option, like, depending on how this button test works, there's a lot of different levels of complexity, but I could try to generate something like this with Grasshopper and have it, you know, in a kind of more programmatic environment like that. It's much easier to create interesting geometry that also fills weird arbitrary spaces like this. So, like, if this structure for the button works out, I can imagine just mostly modeling the button as is, but then kind of weaving them together with the surrounding, doing something like that in Grasshopper. Oh, I think it's done. Let's grab that and see how it worked out. Wow, I think we've got some data. So here is that print straight off the printer. Nice shiny appearance. So these these mostly hollow cavities actually feel kind of great. Like they're very hollow. And it's kind of hard to tell what the quality of the bridging was, but at least since there's a couple of hollow or solid layers up there, it doesn't matter. The first problem I'm noticing is that the bridging in the button itself was pretty bad. So this has got, oh, focus. So there's a kind of a bunch of like loose threads of plastic kind of built up in the button here that are in the way. So that's going to cause problems with the fit. Maybe trim a little bit of that out with the side cutters, but I don't want to take too much. I think that's a reasonable approximation to my 3D model. But I do need to fix that overhang problem, since that apparently is too severe. Alright, so now you can see the hollow part, the sides. This is nice and... this is very satisfying. It feels like an orange or something, like a citrus fruit with segments to it. So yeah, actually that pattern being so satisfying, I could kind of imagine doing something with like a Voronoi diagram with it. It's maybe a little bit too rigid in this axis though, which maybe just means it's too thick. Because these, like I don't want it to be so hard to bend along that direction. So yeah, maybe too thick, but can we try the buttons? Whoa. That's actually quite a click, yeah. So I think that cone was a little stronger than I kind of wanted to hit eventually, but so that needs to be more of a curved approach at the bottom of the cone, or at the bottom of the button. So the bottom of the button needs to have more of a curved approach here rather than a cone, and I need to change the shape such that the bridging here isn't such a problem. Let's see if I can actually get this on one of the buttons here. Feels alright. It doesn't really spread out the force at all. Like you still have to pretty much just press in the very middle of the plunger. I'm not quite centering it there. And this is actually a little bit big, so it's overlapping with those other buttons. I'm going to try cutting it on two sides. That bridging seems pretty fine. I guess the button just didn't have enough of a stable structure for the threads to really grab onto. Alright, let's see. Yeah. Okay, if it actually fits on there properly, it is a little better. Because that bottom layer of NinjaFlex should be totally flat against the paper. That's not so great. Let's try pressing with a smaller object. I'm also trying to make sure that this stays centered on the button, since that'll affect how this works substantially. So that's clearly on the button. I think that's roughly the middle. Doesn't trigger at all if I press it way out here, which is a problem. That's part of what I wanted. And it feels like the NinjaFlex is just flexing too much. Like I need to have more margin for it to flex at the top there. I mean, it's not awful. Like if I had to use these buttons, it would be fine. I would get used to them. They just don't feel as good as I'd like them to. So I think we can do better. I think they need to have more room for travel before. You know, I think it might also just be the stiffness, because as I'm noticing this, I think what I'm feeling here isn't even actually the cone buckling yet. I think it's just the center NinjaFlex pressing in. Because if I press over here where there's more clearance, it actually takes more force and it moves further for the cone to actually buckle. Yeah, see that? I got it a little bit, that. It's also not nearly enough, not rigid enough to where you could press it with a pencil like this in the very middle and the whole thing would act like a single button. But when you press it with a finger, like that right there is starting to approximate, I think, how it felt. Like it goes in as one single unit, and that works, but it just takes too much pressure and moves too far, so. Yeah, I can think of a few ways to improve these. These vertical ridges are really good. So maybe just less of the infill and more vertical ridges. Because I think one thing that helped with this earlier button design was having kind of the Lego style, like kind of plus sign in the bottom, where, you know, two sets of ridges intersect. And I think I want to do something like that. But yeah, I think this might be a good time to wrap up the stream for now. I am feeling like I should maybe get some dinner and maybe think about this a little bit more before jumping right back into the CAD. And take a look at what's on there so far. So all the other stuff we were dealing with, but so there's the centers. Here are the kind of work in progress button surroundings that we'll be modifying. All right, and there's the flex circuit again. Yeah. I think it might be worth just doing some sketches of this outside part too. I don't want to focus too much on the parts of the design that have very few constraints right now until I have the more constrained parts figured out. All right. I think that was a good learning experience for this particular test. Just checking the chat. One suggestion was printing it upside down, which is totally an option. I did that for this other like synthesizer project. This thing. With this, well, actually, I didn't end up doing it for this particular print, but for the prototyping for that project, I ended up making a bunch of stuff like this, which I did print upside down. But on this project, I wanted to be able to do more like 3D button tops. And I wanted to try to get that kind of soft feel for the buttons too, and just design it mechanically so that they can still have enough travel. So it would certainly be a different experience to have like hard, chunky button keycaps, but that's not quite what I was going for in this project. So I think I'm going to keep making another couple of attempts at making a button out of NinjaFlex that has the characteristics I want. Might make a few tests and print them up for the next experiment. But until then, happy hacking, everyone. Thanks for tuning in, and I will see you next time with more projects in progress here.